Hi, this is Dr. Graves from the CSUN Geography Department, back with part 2 of the Retail Site Location Lab. In this part, you will find the location for a new donut shop. In the first part, you used a simple least cost location tool, mean center, weighted mean center, to find the best location for a factory or for a warehouse that would be making multiple deliveries to the donut shops. But now you're going to assume that you are working for a donut franchise and you want to open a new store in the San Fernando Valley, and your job is to recommend a new location. You're going to use the GIS software to analyze the trade areas of existing donut shops so that you can estimate the threshold or minimum number of customers necessary to establish a successful donut shop, while identifying areas of the San Fernando Valley that are underserved by donut shops, places that have a larger than necessary threshold, meaning more customers than they need. And so what you want to do is sort of barge in on the retail territory of existing stores and try to swipe some of their customer. Now, there are lots of techniques for determining trade areas, but in this exercise, we're going to create very simple trade areas by using a tool that creates Thiessen polygons or Voronoi diagrams. And these are just simply shapes drawn around each donut shop so that the border of the trade area is halfway between each of the competing donut shops in every direction, north, south, east, west, whatever. And you should note that the location of the donut shops have evolved by following the logic of the hoteling model that you would have read at the beginning of this lab. There is a dispersed pattern of points because donut shops seek to maximize the number of customers it serves most conveniently, and so they try to avoid direct competition. Not all retail companies follow this logic. So let's go ahead and get started. I'm going to close the measure tool and the symbology windows and the geoprocessing window. I'll click here on the full extent button and zoom all the way back out. Turn off the streets layer and the zip code layer for right now, and we can go ahead and get started by clicking on the Analysis tab. Click on the Tools button from the Analysis toolbar. In the geoprocessing window here, if you still see the mean center, erase that, and then where it says Find Tools, type the word Thiessen, 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 there you go, and select from the list of options Create Thiessen Polygons. The input feature class that you should select from the drop-down menu is, of course, donut shops, and the output feature class is called trade areas. But once again, we have to make sure that we are saving in a location that we have right access. So I'm going to call these trade areas, and I'll click Save. Doesn't like that. Why? Because I left a space. Trade underscored areas, and the output feature, or the output fields, are all fields. So then we will have sales data associated with these new polygons that are going to be created. So go ahead and click Run and wait a moment for the new layer to appear. Well, that didn't take long. I'm going to close the geoprocessing window, and what we see are the Thiessen polygons. You might want to click on the new layer here, Trade Areas, just once, and that would bring up the formatting options, and maybe we will just put an outline around that. If you want to change the black outline to something more dramatic, click on Properties and perhaps choose red. And what you should notice, closing this window, that each of these donut shops has a line between it and its nearest neighbors in every direction that is halfway. So each of these polygons represents the trade area between each donut shop nearest neighbor in every direction. Next, right click on the trade areas and open the attribute table by clicking on attribute table in the pop-up window. And the next thing I want you to do is to sort by shape area. Sort it ascending and then sort it descending. So if I highlight a few of these and then scroll out, you'll notice that these highlighted polygons on the maps are those that are very small, and that there is lots of local competition. If you sort it by descending and highlight the area, you'll see these are very large areas, and they are mostly on the borders of our study area, and that there is less competition. But that doesn't mean that we necessarily want to put a donut shop up here in the mountains overlooking the 210 freeway. That wouldn't be very good. So pause right now and answer a question or two about the data in the attribute table. Now, click on the clear button and then sort by descending and ascending and highlight some of these polygons, and you will notice that these are the ones with the greatest amount of sales. Once again, pause the video and answer one or more questions about the data in the attribute table. One of the most cool things that GIS will do is combine multiple data sets like these Thiessen polygons that you see with addresses or zip code data, or in this case census data, into a single layer. No other software really does that. And so for this exercise, you'll be joining data from the census tract layer, which we can turn on here in the green below. And let's go ahead and click clear here to get rid of all of the selected polygons. And what we're going to do is ask the software how many people live inside each of these trade areas. I'm zooming in a little bit. So in the table of contents, right-click on the trade areas layer, and from the options, click on Joins and Relates and select Spatial Join. In the dialog window for the parameters, set Census Tracts 2018 as the join features. The output feature class is, once again, make sure it's somewhere you can save, and we're going to call this Trade Areas Joined. Click Save. Join 1-to-1 is okay. Keep all target features, check on, and the match option at intersect. And the next step is to expand the fields map. Scroll down until you see Population 2018 and change the merge rule to sum, because what we want to do is add up the populations from each of the census tracts that intersect the trade polygon. And we want to do the same thing for baby boomers 18, workers 18, sum. Scroll further down. I had to expand this window. And for median income, change that to mean. And for per capita income, change that one also to mean. So we get the total number of people and the average amount of money they make. Click OK, and a new layer will appear. That looks very much like the old one, but we can right-click on it, change the symbology from single symbol to graduated color, and change it from join count to something like total population. And now we have a map of the number of people that are in each of the trade areas. Right-click on the attribute table to bring it up. Right-click on the 2018 total population column and sort ascending and sort descending, and then answer some questions about the data in the attribute table. In the last few steps, you're going to calculate purchasing power. Basically, you're going to multiply the number of people by the average income in each of the trade areas. Ideally, you want to locate a donut shop in a neighborhood that has a few competitors, lots of people with lots of money. So to do this, what you need to do is to scroll to the right in the attribute table for your trade areas joined layer and find the column purchasing power, and it may be minimized here, so click and drag to expand the purchasing power column. Right click on the word purchasing power to bring up the pop-up window, select calculate field and click on it, which brings up a field calculator. Enter the following calculation. Double click on 2018 total population, and then times, and then scroll down to select 2018 per capita income. Double click, and then you want to divide that by 100,000. Once your formula looks like this, click OK, and you should notice a series of values in your purchasing power column. For the last element of this assignment, you are to go over to the table of contents and right click on the trade areas layer, bring up the symbology tools, change the symbology to graduated colors if you haven't already done that. Change the field to purchasing power, which you just calculated, and change the method from natural breaks to equal interval. Examine your map. Next, in the table of contents, sort the data by purchasing power. So I'm going to scroll back over here, purchasing power descending, and let's close the symbology window, right click and bring up statistics. Select that. Now we have a histogram of all of the places by their purchasing power. Use the select tool to highlight the rows containing the trade areas or the donut shops with the top 5 and lowest 5 purchasing values. And so the top 5 are here, and you can also select them here. I guess that's 1, 2, 3, 4. Hold down Shift and select them all. Now we can see what areas of town have the greatest purchasing power. That's income multiplied by population. The last step is that you want to turn on your zip code layer and turn on the street map background layer, and you may turn on and off the trade areas map. So I'm going to turn on the zip code layer here, and then turn on and off the trade area map so we get a sense of where we might want to put a new donut shop based on purchasing power. So this is the end of the video. There's a few questions yet to be answered, so stop the video and answer the questions.